Okay, very simple chapter, guys. Chapter 11 talks about the lighting branch circuit for the front entry porch. I want to warn you, Phil, my friend, in the residential, they use the word lighting to mean also receptacle. So as you can see here, they mean also sometimes the word lighting and general purpose receptacles. So don't be surprised when they say we talk about lighting and there's a receptacle stuck into that lighting circuit. So just a quick, I'm going to go directly into the circuit, guys. Right in here, here's your circuit. As always, they always like to analyze the circuit. You have a hallway. Everybody can see that hallway here. We have a hallway right here, and we have a porch, and we have a garage front entry, as you guys can see, and we're bringing a circuit. Here's how this circuit, this is how they decide to do this circuit. And Chris, you can do it any way, shape, or form you want. What they decided to do is they decided to bring a circuit number 15, and I believe it's a 15 amp circuit. It will be helpful if I start mine. I always forget that one. All right, give me 1 second here. So they have one circuit that feed the light and the receptacle in this area. You're going to see in a second here when I fire my smart board, baby. All right. All right. Okay, so hopefully now my PowerPoint presentation is active. All right, so I'm going to go directly, guys, my friends, into this circuit. Here's my circuit right here. They brought the circuit, Chris, into the light, no problem. From the light, as you can see, what they did, they stole a receptacle. So the word lighting circuit implies also general purpose receptacles. So what they did, they took the circuit here, they put the receptacle, hot and neutral, no problem, everybody can see that. And then from here, they came with a switch, and they brought the light to a closet, and they have a jamb switch. They have a jamb switch right here, guys. We'll talk about jamb switch in a second to switch the light in the closet. So that's what they did over here. And they have a three-way switches. I have a three-way switch that actually, right here, if you look at this three-way switch that switch this light from two locations, three-way switch. And then they stole the power and they picked a receptacle from a switch. There is a switch here that switched this receptacle. If you read how they did it, they're in the porch by code, guys. Every porch have to have a receptacle. The receptacle have to be GFCI. Weatherproof GFCI receptacle. So that's what they did, GFCI receptacle, weatherproof. The only thing they did, Chris, is they switched the receptacle. Anybody knows, is it code to switch the receptacle outside? No. Why would you switch a receptacle outside? It's really nice, decorative light, holidays and so forth. You can turn them on and off without moving yourself outside the house. That's really cool. So that's what they did here. And then there's a bunch of lights, as you guys can see. Light for the garage, these three lights. They put them on a three-way switch. They put these lights on a three-way switch where they can turn them on and off from here or on and off from here. That's it. Is this the best way of doing it? Are there other ways of doing it? Yes, absolutely. So they have a hallway light that turn on and off from two locations, and they have a porch light and a garage outdoor light that they can be switched from two locations, one in the garage and one in the house. A switched receptacle for the holidays. And that's about it. And a jamb switch right in here. Can you guys see that jamb switch? That every time you open the closet, it's like the fridge. When you open the fridge, what happens to the light in the fridge? Comes on. Jamb switch, the same thing. You put a jamb switch in the frame of the door. Every time you open the door, the closet door, the light will go on. You don't have to do that, but that's nice instead of flipping a switch that turn the light in the closet. Any questions, guys, about that circuit? The only thing I didn't mention is these two are going downstairs, part of a different circuit, and this is also part of a different circuit. So these are not part of that particular circuit. Any question? We know what the hallway is. Every hallway 10 feet or more, you need a receptacle. Good idea, even if it's 8 feet, to have a receptacle. A porch needs a receptacle, GFCI weatherproof receptacle. It's a wet location, damp location, and a porch. The outside light have to be rated for wet location because they're wet location. Do I need to have two switches, three-way switches, one in the garage and one in the house to turn the light outside? It's a good idea. Do you need it by code? No. Any question, guys, about this circuit? See how simple this circuit is?
What do you use for a box holding conductors in the ceiling?
What do you use for a box? Very good, very good point. 1, 2, 3, 4, and each one of these, the top is having a hot. There's two number 14 here, and this side is have two number 14, right? And the bottom, this side is coming 3 number 14, 3 number 14, and this guy has a 2 number 14. Are you talking about this one?
Yeah.
This one. So we have, how many conductors we have? 9 conductors. You can't have a box for 9 conductors, number 14. No box, nothing.
I can't find it the standard size.
Yeah, yeah.
You'd have to just go take something else.
No, they have 9 conductors, number 14. 9 conductors, number 14.
Well, you gotta have a clamp.
And a ground, so that will get you 9 number 14 plus a ground. That will get you another one. Internal clamps, that will get you another one. I'm sorry, that number 14 should be right here. So 9, they'll give you 11. Should be able to fit. Still number 14, 11 of them. Any question, guys? Good point, though. Good observation.
I just went through the standard sizes and the code.
And you couldn't find it? Metallic ones? Yeah. The metallic one that you can get them? Wondering if the box here. You have a box here, plastic. These would be probably most likely plastic. I have 10 number 14. This can handle 10 number 14, the standard one.
Okay.
10 number 14.
Sure.
So we're short one.
Yeah.
But clamps, they have no clamps. I don't think they count these as the clamps internally. So if you get the clamps out, no clamps, you're there with a box like this, 10, right? Because we're short. So I think that's how we'll probably get. There's nothing, no studs, nothing coming out of it. Very good point, Chris. You're thinking box fill calculation. Any question, guys, about this circuit? Any question about this circuit? So that's basically the second thing what we're going to talk about. The second thing, guys, is damp and wet location. Damp and wet location is defined by code. If you go to Article 100, a wet location is a location that will be saturated by water, be it indoor, be it outdoor. Damp location or dry location can have some water at a certain time. Damp location is not saturated with water. There's a couple of examples of damp and wet location. Location exposed to the weather. If it's directly exposed to the weather, it's wet location or in a wet location. Partially protected, like porches, partially protected. Open porches is a good example of that one. Under roof is a second example. Canopy, that will be your damp location. It's damp, but it's not wet. Basement, some basements are considered damp locations. So who cares? When you have a fixture in a damp or wet location, you need the fixture to be rated for damp or wet location. That's all. So can I grab that fixture right here and go put it outside or in a porch? No, it has to be rated for damp or wet location. Suitable for wet locations. So fixtures must be suitable for the location, wet for wet location, and damp for damp location. And of course, if otherwise, it will be dry location. Otherwise, it will be dry location. Okay, we talk, give rules for receptacles for year. Okay, door jamb. The door jamb, guys, we'll talk about the door jamb switch in a second here, the plunger. There you go. The second, I don't know how many of you guys install a door jamb like this. The door jamb switch, you don't have to do that. What they did, there's a closet. And instead of having a snap switch right next to the closet door to turn it on and off. They want the action of opening the fridge, the action of opening the closet is at the same time turn the light on. So what do? You assemble this one in a box inside the frame, and that jamb switch is normally most of the time. So this is normally closed. How are we going to say that? Normally closed, held open. Normally closed, held open contact. So it's normally closed, but there's a pressure in it, held open. So when the door jams on it, it opens it, so the light goes off. When the pressure goes off that jamb switch, the plunger will push the contacts to close, right? When you release the door, open the door, and the light will go on. So that would be a normally open, held, close contact. Normally open, held, close with the force of the door. So long story short, when you open the door, my friend, you release the pressure from here. And what happens to this contact here? You close, and up it goes with your light. How do you wire it? Exactly what you guys have seen over here. The way they're wiring, hot, neutral, exactly like any other switch. Except do not forget that this is also a switch. And what do you need with a switch in the 2011? You need a neutral. Any question, guys, about this? For all practical reasons, this could be a snap switch, but they went a little bit more fancy. They want the action of opening the closet will at the same time open turn the light on and off. Any question, guys, about the jamb switch? For all practical reasons, you can have a pull chain to turn the light on and off for a snap switch. So you don't have to do this. Okay, so that's basically it. Jamb switch, lumineers, fixture. I don't know if we missed anything. I want to remind you guys that everything, this circuit in the porch, as well as in the other porch, okay, the receptacle and porch have to be GFCI, right? You have to. Damn wet location GFCI. Weatherproof, has to be weatherproof. The second thing also, the hallway has to be what? What the hallway need to be? Arc full circuit interrupter. So the hallway have to be arc full circuit interrupter. So this circuit breaker that you have to be GFCI/AFCI or just AFCI, and the receptacle outdoor have to be GFCI. So keep in mind GFCI, AFCI.
You know, at the Square D seminar,
He said
it
there
has
were.
both, but if the GFCI doesn't really work,
Yeah.
is it still okay if it put it in and it's listed as such?
I've never installed one that has both of them. I believe they have. If you have a GFCI, AFCI rated circuit breaker, it must work. You can't just put it if it's not working. Most of the people, guys, what they do is put an AFCI circuit breaker right now and a GFCI receptacle.
His point was that it is listed as such, but it's too slow.
I put disclaimer, this is their point of view. You know, it would be really nice to see Collar Hammers and Siemens' point of view too. Yeah.
What's the hierarchy of the manufacturer as far as volume and credibility? In your opinion? I mean, for example, telecom, Siemens is considered very, very high.
Yeah, if you want to rate electrical equipment right now, if you have Square D, Siemens, Cutler, Hammer, and GE are the top 4 in electrical equipment.
Square D being the most popular.
Yeah, it's residential and a couple of other things. Yes. At least here. Any question, guys, about this? Any question? The last thing I want to show you about this chapter is, so we got that one. So straightforward. What I hope, Rob, is by going over this, guys, you will get more and more into laying out and circuiting. Here's your chandelier that you will be putting in your hallway if you so decided. So here's all these options that you can put in the hallway. Again, you can, for all practical reasons, you can put just a socket and a lamp. So these are one of the things, guys, when it comes to lighting a residential that you have to be aware when you bid a job. The lighting. Most of the electricians, they give $15 allowances for the light. If the owner wants more fancy lights, they have to buy the light. Because light, you can buy a $10 fixture or you can buy a $150 fixture. So lighting is a whole different animal. So a lot of people in residential or other projects, they put a budget, they negotiate with the owner. They said, here's what we have a budget for your light. If you want to go higher than that, you have to basically pay us. This is a light that you can use outside in a damp location, couple of fixtures. And if you need more, just visit Menards and you'll see you'll have more than you can even imagine. Wet location. Here's where the damp location that we talked about, guys, under the canopy. Three-way switch, the damp switch. What they did, a couple of things I'd like you guys to look at is they keep doing calculation for every circuit. And I don't do it in residential, but they added all the volt amp and they came up with this 765 volt amp on a 15 amp circuit. So what does that mean? It means if you have a 20 amp circuit, take this. Here's my 20 amp circuit and 120 volt. So if I take my 20 amp multiplied by 120, what would that give me, guys? 2400 volt amp. That's non-continuous load, right? Did they do it right? 2400. And how much am I loading this circuit by? 765. So that's just to give you an idea that you're not overloading this circuit. Non-continuous load, residential. So the reason why they keep doing all this calculation is to prove to you as we are not loading the circuit. Remember, the circuit's 15 amp. It can give you a 2400 volt amp, and I'm using less than half. Right? Less than half.
15 times 120.
Did they say 50? Oh, they're using a 15 amp. Can you do my 15 amp? Yeah, they're using a 15 for this one. 1500, 15 amp. Thank you. And if you use a 15 amp circuit, what did they put 20? And that will get you what? 1500? 1800. 1800. Exactly half of that, almost. 1800 volt amp. Am I okay? Have I exceeded the limitation of this circuit? No. So that's why these are cool stuff. Okay. Anybody want to volunteer wiring this? You guys want to volunteer wiring that baby? Based on the layout? Let's do that one because we haven't done that. Let's just do this wiring. Grab your calculation. Did you do it? Grab your book, guys, and let's do that one together. In order to do this wiring, you have to have the layout right in front of you. So make sure you have your layout. Otherwise, there's a trillion ways of doing this. I'm going to go open my book right at the layout of, which is page 300. Okay, I'm going to have my 300. I'm going to start with the branch circuit, guys. I'm going to use, let me use my convention. My convention, this is hot, black is hot. Blue is switched hot, right? Switched hot. Red, travelers. I will use red for travelers. You guys have issue with travelers. For the travelers. And green, I'm going to use it for neutral. This is my convention color coding, and let's go ahead and do it. Okay, I'm going to start with, as always, I'm going to start with the hot. Where's my hot? There. So if you guys look at the circuit coming from the top, if you look at the page 300, I'm bringing the hot to the light. Which light would that be? This would be this light. So I'm bringing the hot coming, I'm bringing the hot right here. Can you guys see that? To the light. Right in here, right? I brought the hot to the light, and from the light, I went to the switch, to one of the switches. So I went from here to here, right, to the switch. And also, from the light, I went to one of the three-way switches, brought the power to the three-way switches. So I brought the hot also to the three-way switches and powered the three-way switch, this three-way switch right here. Right? Can you guys see that? I brought the hot to the first three-way switch. And I also took the hot to the light. And from the light, I went to the switch. Okay? And so I'm going to stop right here for this moment. I'm going to stop right here. And So I took that one, and I also at one time took the hot. Where did they take the hot? They took the hot to the light. I took the hot. Are you guys with me up to this point? Can you see what I'm following? Then they took the hot to, that's three-way switch. That's it. That's all what the hot, yeah. There's also a switched hot going to the receptacle. That's just a switched hot. Any question about the hot? Let's take the neutral. Took the neutral. The same thing, the neutral came from right in here, landed on this side of the neutral, right? To this fixture. And from here, I went and I took it to this side of the receptacle. So I powered my receptacle, right? I powered my receptacle. And also from this baby, I went and powered this fixture, put it on that fixture. And from this fixture, I went down to the switch and I landed it just on the switch. Just on the switch. And also I took a three-way and brought it from this fixture here and landed it right in this box. Did I miss anything? We brought the neutral to all these applications. We brought the neutral to all these applications. Now we brought hot and neutral to every single one of them. Hot and neutral to every single one of them at this point. Okay. What they also did, guys, the neutral, they grabbed the neutral and they brought the neutral directly to this switch here. And they grabbed the neutral and they brought the neutral to this light. And from this light went to this light, and from this light to this light, right? Did they go light to light? Yep, light to light. And from here, they went and took it to the switch. So I brought my neutral to all the fixtures. Are you guys following with me based on what they're doing in the layout? So I have my neutral going to all the switch. Neutral have to go to all the switches and all the lights. Just think about it. All the switches and all the lights. Is the neutral at all the switches and all the lights? There's one more I have to carry. The way they did it though, they took the neutral from right in here, just from right in here, and they went all the way and they landed it right here. If you see, for conductor, they landed the neutral right into that switch. Just landed. Any question, guys, about that? Any question about the hot and the neutral? Now the next, we're going to be doing the switched hot and the travelers. Switched hot and the travelers. Any question about that? Then we count how many cables and conduits and we do. Any question about that? Okay, let's do it. Let's do travelers. My travelers, as you guys know, what they did is they grabbed one from here and went all the way to here, and one from here went all the way to here, right? This is my travelers going between these two three-way switches to switch the light in the hallway. Switch the light in the hallway, right? That's my hallway, my light in the hallway. My light in the hallway. And then travelers, I brought one traveler through this light. I think they went through the light. Yeah, they went through the light. They didn't do anything with it. They just came over here, didn't do anything to it, and came and landed right here. The same thing with the second traveler here. Came over here, sat here, and came back all the way to this switch. All the way to this switch. These are the travelers, and this landed also inside the box. It landed inside the box. These are the travelers for the garage and the house. Okay, so we have my travelers. My travelers are there. The last thing, guys, is the switched hot. What's my switched hot? Let's talk about switched hot now. Now, I wanna remind you that these have to be powered. These switches have to be powered. So what they did, they grabbed the hot from here, they jumped it and jumped it. Now I powered the switches. I powered these two switches, right? I powered these two switches. Now switched hot Here's my switch hot number 1, landed right into this. Perfect. Now my light can be turned on and off from that switch. What else do we need? There's also a switched hot that's coming from right. Can you guys see that baby here? Coming back. Okay. Coming back. It has to go back to the fixture, but via what? Back to the fixture via the switch. So what they did is they took this one with these all the way here, landed here, and came back with the neutral to land. See how they did it? I'm following the layout in the book. They brought the switch to the switched hot to the other three-way switch, and then they carried it over to the lighting fixture. That's based on the layout. Okay, what else? What else do I have? Not there yet. How about switched hot here for these lights? Take this. Here's my switched hot. Tie it here. Tie it here. Now I can switch these. Carry it all the way up to. How am I going to switch this? Did I make?
You've already switched that one.
Where's that? No, it should be from a three-way switch. Oh, this is wrong. This single-way switch is not for that particular one, guys. This single-way switch is actually for something else. Here you go.
GFCI.
There you go. So that's the treble. That's the switched hot. The way they're doing it. I could have done it the way that I did it. So that's switched hot is for all the outdoor lights. Switch them. Now what they did for this is, well, not here. The traveler switched hot. Back to this switched hot. This switched hot, my friends, came directly and switched this receptacle. Done. Now some of you might say, what the heck is this doing, guys? This guy and this guy, they're part of a completely different circuit that's going somewhere else. Completely different circuit. Oh, I didn't power, I didn't switch this one too. You have to come over here and switch this fixture. You wired it. Any question, guys? Any question about wiring layout? Any question? So tell my friend, you should be able to look at these, please, as we go through, guys, and be able to follow up the layout and the wiring and the hot and neutral. This will make you the best, as good of an estimator and a designer as you can get. If you can visualize the installation, understand how the neutral, remember, every switch, every light have to have a neutral. That's a must. Every light have to have a switched hot. That's a must. Travelers, if you have a three-way switch, you have to have two conductors dedicated between the three-way switches. That's called travelers. Must. And then from one side of the three-way switch, you have to bring hot. From the other side of the other three-way switch, you have to take the switched hot. If you understand these concepts, you never get wiring wrong again. The reason on the power, my friend, the reason why we switched this receptacle is because they wanted switched receptacle. You don't have to. I could have stole the power. Can you see the power from here? And land it directly on this receptacle, and that receptacle will be hot at all times. Then you have to move yourself out and turn the Christmas lights off. And that's for somebody 210-pound gorilla like Chad. That's inconvenience. Maybe we should move out to lose more weight. Okay. Any question, guys? Any question, my friends? So I want to remind you that these two are part right here. These are part of a different circuit. So we're not going to wire it at this moment, okay? So don't get confused. They're in the same box, but they're part of a different circuit. Part of a different circuit. I'm sorry, did you? Okay. No? Here's a future problem. Take this. That's only in 2011. Suppose I have a neutral with this switch. Does this neutral here count for this switch too? based on the code it does. If this switch is powered from a different lighting circuit on a different pole, or actually in the same pole, you could easily, and you change this one into that in a switch that you need a neutral, you could easily trip your arc fault circuit interrupter. So be very careful, guys. When you have two switches in the same box coming from two different circuits, pull the code right now. This will mean the code has a neutral in it, but this neutral is really not that circuit's neutral. So make sure you bring a circuit neutral when you come here. I would probably bring a circuit neutral with a neutral from that circuit that feed that switch. Otherwise, in the future, as I said, you change it to a dimmer, right? Or a motion detector or something. Then you need a neutral. Guess what? You're going to go grab the neutral that's coming from a different circuit. Now remember, this is an arc fault circuit interrupter that will trip the arc fault circuit interrupter. Or could trip the arc fault circuit interrupter. Okay, so that's basically what I wanted to show, guys. I have this as a PDF file. Okay. Any question, guys, about this? Any question about this? I can't emphasize, Ashley, my friend, you guys are you're wiring people. So, but for those of you who don't know how to wire, you must know how to wire if you're going to be an estimator, project manager. The more you know, the better. Nick, and we have the whole year. You come to me and say, Chad, I would like to go wire these in the lab, and we have enough equipment, if you haven't done it, to get you there. I will help you. All these things that I'm showing you, right, guys, I can get you that sheet right now. Go to one of our labs and you can wire it. Right? Am I right? What's
You already got us wire most of the stuff like this.
Awesome. Awesome. So it should be a second nature for you. Okay. That's all I have for that one. I want to switch track. I'm going to give you guys 5 minutes and then switch track to calculation.